Hello, today we will look at managing parameters of functional blocks in Mini PLCs. In previous videos, we discussed functional blocks and parameters that we can set through the properties of blocks, such as setpoint for counters, duration of delays, or pulses for timers, and other similar settings. The good news is that the value of these parameters can be dynamically changed, meaning they can be chosen during the program's operation or even set from screens or over the network. Let's figure out how to do this. Today we will consider two most common cases. The first case is when we control the parameters of a block using physical signals. For example, a switch. The second case is when the block's parameters will be set from a screen. For example, let's say we have a timer and a pulse generator of a certain duration. Suppose it is activated by some input signal. A switch connected to the second input determines the duration of this timer. To select the duration needed, we will use such elements from the quick access panel called Write to Functional Block. I will add it to the workspace. In its properties, we select which functional block we will be writing values to, and which parameter of this functional block we plan to write. For a timer, for example, only the pulse length parameter is available. For the blink block, for example, the off and on duration parameter will be available. It all depends on the specific block. To choose one of several values for the pulse duration, we can use the selector block. This block is already familiar to you if you have watched our previous video, or if you have already worked with PR. I take the selector and connect it to the second input, which will determine the pulse duration of this timer and use two constants. Note that writing to a function block occurs in the format of an integer value, and in cases of timers, durations of pulses in milliseconds are recorded. So to set, for example, for our timer pulse duration of 5 and 10 seconds, in these constants, I need to select the integer value type and respectively 5000 milliseconds and 10,000 milliseconds. Instead of constants, there can be variables that are calculated based on certain formulas, depending on the logic of your block diagram. Thus, you can tie the duration of this timer to some mathematical formula. Here, I will let your imagination come into play. If we want to control the timer from the screen, we will use a similar construction. Suppose we have a timer that starts from some input signal and controls some output. And I want to set the pulse duration from the screen. For this, I will also use the functional block writing block. Now, from the drop-down menu, we select the timer TP2. Note that the specific name of the functional block is written on it. I have TP1 and another is TP2. And I also choose the name of the variable pulse length. I will write some local integer variable into this timer. For example, I will call it pulse. Since I need to write an integer value in milliseconds to the block, and setting these milliseconds from the screen is not very convenient, and the operator is, after all, more accustomed to working either in seconds or in minutes. So I will add a couple of mathematical functions here to scale this variable. If the variable pulse, which I will set from the screen, is, for example, in seconds, then to convert it to milliseconds, I need to multiply it by 1000. For this, I add a multiplication block, add a constant, and connect them to the multiplication block. Note that my variable pulse is not non-volatile, and therefore akYtec ALP warns me that this variable is not being recorded anywhere. As soon as I add this variable recording to the screen using the I/O box, integer or real tool, this error will disappear and everything will be fine. Now let's set up this input-output. Let's say I will have 2 digits in total, and there will be no decimal points, naturally, because it is an integer. I will label the text before pulse and the colon, and the text after seconds. I will stretch the size of this element so that all symbols fit. It turns out that this way I set a number in the range from 0 to 99 seconds. Since I only have 2 digits, I can basically add a range control where I can manage this variable. Say, for example, I set some number of seconds in the range from 1 to, let's say, 20. Since we still want to set this number from the screen, don't forget to check that the parameter editable that we edit is set to yes. Once again, I remind you that we set the value of an integer variable in seconds from the screen. Then on the diagram we multiply them by 1000 to get milliseconds. And using the block for writing to the functional block, we write into the required timer. By the way, using such a construction with the writing block to a functional block, for example, you can emergency stop this timer. As you remembered from previous videos, I said that the timer does not react to its input at the moment when it is already generating a pulse, but it will react to the parameter of pulse duration. And if during its operation you change the pulse duration it should emit, then this way you can either extend the timer's operation time or emergency stop it. And suppose that this construction serves us for emergency stopping the timer, and the command for its shutdown will be an emergency signal on input 2. Then we connect normal operating time of the timer to the second input of the selector. In case the emergency is turned off, for example, some number like 5000 milliseconds. But in case of an emergency, we will write some small number into the timer, for example, 10 milliseconds. That is clearly less than what it managed to count. Then during the operation of the timer, if we activate the second input, then the timer will be written with a pulse time of 10 milliseconds. The timer will see that it has issued a pulse already larger than what was assigned, and it will turn off. After we remove the emergency effect, we will be able to start the timer with a normal pulse duration, 5000 milliseconds or 5 seconds. It would also be nice to add some kind of a lock to prevent this timer from being turned on at the moment when there is an emergency. For example, in this way, using the AND and NOT construction. Besides the writing block, there is also a data reading block from the functional block. In it, you also select the name of the functional block with which you intend to read data and the name of the variable you want to retrieve. That is, this pulse duration you specified in the timer. You can read it and somehow use it for the further algorithm. And now let's get to the practice of information from the 10th video. We will start the simulation mode and see how our diagrams works. Activate the first input, and the first output should turn on for 5 seconds and then turn itself off. Let's try again. But if during the operation of this output and accordingly the timer controlling it, I activate the second input. Then the output and the timer will turn off because the timer is giving a time clearly less than what it managed to count. And to control the timer connected to the fourth input and the fourth output, I use the screen. I set the pulse duration I need, for example 10 seconds. Start the timer with a button, and the output controlled by this timer will be on for 10 seconds. In principle, just the same, setting a new setting from the screen, you can emergency stop it, for example, like this. Or extend the operating duration by increasing the setting. Well, managing the parameters of functional blocks is not complicated, and the topic turned out to be quite interesting. Write in the comments whether it is convenient for you personally to change the block parameters in this way, and don't forget to subscribe to our channel. Be among the first 1000. All the best. See you in the next videos.